Welcome to another video series from the National Graphene2D Association. Today I'm joined by a good friend and fellow advisory board member, Adrian Nixon from Nixene Publishing. For those who don't know Adrian or Nixene Publishing, it is a graphene-based business journal that looks to dissect down some of the latest research, latest company developments, and how well companies are faring in general within the graphene industry. So Adrian's a perfect person to join me on today's segment, where we discuss some of the hot topics of graphene at the moment and what is going to be emerging in the next few years. So thank you for joining me, Adrian, and welcome to the NGA2D video series.
It's a pleasure, Liam. It's nice to see you again.
And you too. Now, I would like to kick off, because you see a lot of what is going on around the graphene industry, both in the academic side and both, commercially. What graphene applications would you consider to be, hot, or, at the moment, and how is the commercialization coming along? Like I said, are we seeing them just on the academic side, or are we seeing some of these topics of interest actually making it to real world products?
Yeah, well, as you know, we monitor both the academic side of things and the commercial side of things. So we see both sides. Rob Wielden, who's our head of operations, who you know very well, he has been doing an analysis of the keywords that we're using in the journal. So we developed some standard analysis keywords that go on each page. And we did a word cloud analysis, and the one that leaps out most of all is graphene composites, specifically polymer composites. That's a big thing. And that seems to be gaining a lot of traction. Interestingly, the research and development activity we're seeing more in Europe, the commercial activity we're seeing elsewhere. So you'll remember, well, in the UK, there's a niche supercar manufacturer, BAC Mono, that sports car, the Geek House and the NTI. Yeah, you've seen that one. But that's quite a niche application. They've put graphene polymer composites into epoxy resin carbon fiber and made it 30% lighter. So power to weight ratio is important, so this supercar goes even faster. But the big commercial one is something that the insiders in the industry, and you'll know about, is in America with Ford cars. So there are, at the last count, there are well over 1 million Ford cars on the road now with graphene in them, and nobody would ever guess. That's a massive thing. We're also seeing graphene going into composites in Australia. We can talk about that maybe later. But then the other type of composite which we're seeing, it's not quite commercial activity yet, but it's just coming out of the lab and into field trials, is graphene in asphalt composites. So it looks like graphene is going to make our roads last longer and we'll have less potholes.
Yeah, but there's been a lot of activity on the road side. I'm gonna say I've seen that from Italy to UK and other places. So no, it's good to know what's actually piquing people's interest at the moment, both in the graphene field and and beyond into the end use markets really. So it's good for people to have an idea of what is here right and now.
Yeah, and it's important to say, Liam, as well, that this whole area is moving so fast. I mean, you and I are struggling hard just to keep up with the just sheer amount of stuff that's happening.
Yeah, agreed. There is a lot going on, which is why it's great to pigeonhole a few key areas here, which are for people to take a look at. And that is going to bring me on to the next one, because obviously that's what's on the here and now.
Yeah. But
what applications are you actually seeing that have just started emerging, and we're starting to see a bit more of, and could potentially mature over the next few years?
Good question. I think the biggest one on our radar is graphene in concrete. So again, Liam, you're familiar with this. Maybe the viewers we'll probably have a mixed audience, so I'll just expand on that a little bit. You put a tiny amount of graphene into concrete, so this is going to be 0.01% by weight onto concrete, and you increase the strength, the compressive strength of the concrete by 25%. It's absolutely insane.
Yeah.
Tiny amount has a massive, more than double digit improvement. And what that means is that concrete and cement manufacture accounts for something like 8% of global CO2 emissions. So if you can make concrete 25% stronger, potentially you can use 25% less concrete, 25% less cement. You could take 2% off global CO2. And people are looking seriously at this at the minute. The industry is a bit conservative, so it's taking a little while to cascade through.
Yeah.
But the pressure behind this is just going to be really, really strong once people really wake up to discover what graphene and concrete can do. So that's the big one for me.
Yeah. What kind of timeframes are we looking at with that?
Yeah, it's tricky. Well, we've already seen one building go up in Mexico, in Cancun. You're probably familiar with that 21st Century Convention Center at Cancun on the Yucatan Peninsula. They started off putting graphene into concrete roads around the site. And then we don't know a lot of technical details at the minute, but then it went into the seaward facing wall of the hotel for the convention center that was being built. And it was designed to improve the porosity of the concrete. And then we found out later that it's actually gone, the builders used graphene concrete to build the rest of the hotel and the convention center complex. There are trials as well going on that we're hearing the edge of in secret in Europe as well. So I guess to answer your question, probably I would say maybe a year, 2 years, when we'll start to hear much more about this. And then the whole area will just go bang, take off like mad.
Oh, so quite short time frames then.
Yeah.
Yeah, just because obviously you see quite a lot of what's coming out, and that. Although I am quite surprised you haven't mentioned sensors, because that is one that I've seen crop up quite a lot.
Yeah, there is a lot of work going on in sensors. One that you're probably familiar with is Hall sensors.
Yeah.
These are, just for the viewers, they're everywhere. They're in all sorts of electronic devices, but they can sense magnetic fields. And the more conductive the material, the better the sensor is, and the more reliable it becomes. I think you're more of an expert on this than me, Liam, but graphene seems to be uniquely positioned to make these particular types of sensors very easily. And there are a couple of companies just started, in fact, probably this month really, to commercialize these things.
Oh. Good to see the developments are coming on. I'm gonna say, have you seen much recently coming out on sensors for COVID, for example? Seeing it's a
yes.
It's a current topic, and you see a bit here and a bit there, but it's how many are like almost ready to go as point of care diagnostic sensors, or is this going to be something it's going to take so long to get ready that it's going to be over before?
Yeah, good point. Right, the eye-catching work that we saw that came out of the research labs was done in Korea, where they developed a graphene field effect transistor. So if you can imagine a sheet of graphene and you've got like little functional groups that can detect the virus sticking up. When the piece of virus lands on the molecule here, it changes the conductivity of the graphene. You can pick up so you can detect COVID with quite exquisite detail. This one detects the spike protein on the cell, so that's how it works. They reckon they could detect down to 1 femtogram per milliliter, which is insane. Yeah. I can't remember, is that something like 14 knots, and there's a decimal point, then about 14 knots and then a 1. So it might be something along that line. It's not much anyway.
I think it's 10 to the minus 15, isn't it, femto?
Yeah, so it'd be about that. Yeah. Tiny amounts, so very, very sensitive, but that's just in the research labs. The one company that we do see that's making these things seems to be making particularly COVID sensitive field effect transistors, and they call them biology gated transistors as well, is a company called Cardia in California.
Right.
And they've developed graphene field effect transistors where they've got something like 15 individual pieces of graphene inside the chip, so 15 different sensors. Originally, I think that was all just to do the signal processing. So you make many measurements and then add them all up and you can improve the signal. they've got so good at it now that I think they can actually split them up, so you can have several different types of sensor on one chip, which is really cool, and probably get results in minutes. They're definitely one to watch, and they've got the ability to produce these chips by the thousand. You and I are both involved with Xena and the AMPT initiative, the Advanced, what's it called?
Materials Pandemic Task Force.
Yeah, thank you. Advanced Material Pandemic Task Force. I was chairing a panel last week, and Ross Bundy from Cardia was on that panel. So he and I were talking about that. So this is all common knowledge. Yeah, so the video's available now. Xena's just published that.
Good to hear.
Yeah. So yeah, there's a lot going on with sensors.
Yeah, there's a lot going on in a lot of places, which it's good to get your insights into what's happening. So that's covering some more of the application side. Now, on a slightly different track, we know a lot now about the fundamental science of graphene. A lot of research has been done over the years in different forms and different types of graphene. Now, are there actually any interesting scientific developments still coming out, at the fundamental academic level, or is it just the commercial that we should look at now?
Yep. Where to begin? I interviewed Andre Geim a few months ago at the NGI, and we were talking about the latest research that's coming up in graphene, and he was saying that graphene keeps on surprising people. The first one, I suppose, was that's been happening recently is twistronics. You're familiar with that. Let me switch my background off for a minute so I can show you a model of graphene, and we'll do that. There we go. The main reason is that I want to show you one of these molecular models that you'll be quite familiar with, Liam. Twistronics is, graphene isn't a superconductor, as you well know. It conducts electricity better than anything else that we know of. But what researchers have found is that if you place one layer of graphene on top of another, so you've got bilayer graphene, and then you just twist it slightly, then roughly by about 1 degree, then all of a sudden what happens is that the graphene starts to become a superconductor down at around about 2 degrees Kelvin. Now that's really cold, minus 271 degrees centigrade. But the point is that nobody ever expected that, and nobody really knows why yet. They think it's connected with moire patterns that occur, and the way that the electronic orbitals interact when you start to twist these things. But it's still puzzling lots of the researchers' minds at the minute. So it's an active area going on. So that's one thing that's gone on. Another one was that, again, this has happened just this year. Graphene has acquired 2 new superlatives. So, what the superlatives are: graphene is the strongest ever, the best conducting ever, the best ever. We hear a lot about this. But what the researchers have done now, I can't remember exactly where this work was done offhand, but they draped graphene over tiny little pits drilled into graphite, and so you have single crystal graphene popped over the top, and that's graphene with no defects. And then what they did was they used an atomic force microscope. You and I know what that is, but for general viewers, it's a very expensive pointy sharp stick, and they prodded the graphene over the hull to make it sort of bend in like that, to see how many times it would take before you break things. Now, you'll be familiar that with fatigue. So if you get let's say, for those of you old enough to remember Uri Geller, you could take a spoon and bend it. And if you bend it enough, what happens is you get lots of cracks, fatigue cracks, and eventually it'll break. And it probably takes about half a dozen times before you could actually snap a piece of metal. That's roughly what you do with graphene. The researchers found it took 1 billion times to bend it before it broke, and making it the most fatigue-resistant material ever. And that work was published in March this year, so just a few months old. The other thing which was done was a team at Manchester University did a very similar experiment. So they took a sheet of graphene and put it over a hull. This time it's like a cylindrical pit. So it's sealing the hull. And they put some gases into the hull. So they put helium and a range of other gases in. And if the gas escapes, then what would happen is the pressure outside would force the graphene on top to bend like that, yeah?
Yeah.
So you'd be able to tell if anything was leaking through the graphene. Alternatively, if something was coming in from the outside and getting in, then the graphene over the top of the hull would bend up like that. It would balloon over. What they found was the graphene stayed perfectly flat. So the pressure was equal on both sides. So nothing was getting through. And when they ran the calculations, they found that with helium and everything upwards, then graphene is the most impermeable material ever tested. And the researchers calculated that a single atomic layer of graphene is equivalent in permeability to a kilometre thick wall of glass.
That's quite an impressive.
Yeah, and that's just two of the bits that, well, three of the bits of the latest research have been going on this year. There's more
barrier coatings. It's been used in barrier coatings a lot, so you can see why. Yeah. And likewise with the fatigue resistance, it obviously make it useful for the composites that we're.
It will. Once people start to make graphene on larger and larger and larger scales, this stuff becomes important. At the minute, you and I know this is done down at the nanoscale, so it's very tiny.
But you can transfer it to, you know, the bulk properties of a material, then it has a lot of use.
Yeah, it does.
Well, that's quite interesting. A bit more than I was expecting there, actually. So if we shift the focus back to you know, the commercial side, you know, from the academic to the commercial side, obviously we've talked about what commercial applications, you know, are hot at the moment and people are interested in. But what would you actually say as, in terms of the actual products on the market, are the most interesting and say like the most innovative out there at the moment?
Well, the biggest example that sort of become a commercial success are the running shoes. You know, the Innovate.
The Innovate ones, yeah.
You know, they've got graphene in the rubber in the soles, and the graphene. These are for elite runners and various athletes, but they're also available to the general public, so anybody can buy them. It makes normally the rubber for these things has to be very grippy. For the athletes to grip, but also it has to be strong, so it lasts a long time. And previously, these running shoes, the compound they use was grippy, but it wore out after about 200 kilometers. So they put graphene in, and now the soles are lasting so long that it's the uppers that are wearing out, and they've had to put Kevlar on the uppers to actually maintain the strength of the shoe. So that's one. Anybody can buy those now. By the way, I'm not getting paid by Innovate or anybody else to promote any of these things because we like to be independent. There's a company called Aura that makes headphones, and they're made with CVD graphene. So the shoes were made with graphene powders. This is graphene film, and they're actually taking, I think it's about 5-layer graphene, and they're putting it across the membrane and creating a loudspeaker out of it. And they're finding that it can reproduce a fantastically wide range of frequencies, which makes the sound quality brilliant. And they can be bought now. So that's another good one. And then finally, the one which you can't buy just yet, but you will be able to do soon, is a company called, or product called Space Mat, by a company called Space Blue. I think it's a spin out of Manchester University. And they're taking shredded rubber tires, and they form rubber mats from it. Nothing new there. People are doing that already. The thing is that the rubber mats, they'll break off, and you end up with bits of black old tire all over the place. But if you put a bit of graphene in with some natural rubber, then what happens is that that rubber graphene composite holds the recycled tires together better. And now you can bend these mats, you can tread on them, rub them, and the stuff doesn't come off. They look like new ones. So you can recycle old car tires, and as you know, that's a massive issue. Yeah, so watch out for them.
Oh, the interesting couple I've not come across myself, especially the mat one. It's like I said, always interesting to see what you see coming out, because you all seeing guy of graphene is.
No, you absolutely. Yeah. I'll introduce you to the guy behind the Space Map, because he's really good.
Yeah, it'd be quite an interesting one, useful one to follow up on that one, I think.
Right, fine. We'll have a conversation afterwards. His name's Vivek.
Yeah. And that leads me on to another one though, because you just talked about different types of graphene and different types of products, from graphene powder to CVD graphene films. And I say there's a lot of graphene products emerging and has been out for the last, few years now on the market. And we know there's like a number of different types of graphene, from like CVD to powders to graphene oxide, reduced graphene oxide, graphene nanoribbons, and so forth. And what is the type of graphene that you see emerging most in commercial products, and why are those types more prevalent than others?
Good question. This goes back to sort of graphene hype. When graphene was first isolated and then won Nobel Prize, you and I both know that everybody came out of the closet saying it's the most wonderful material ever and it's going to change the world. And everybody thought they were going to get graphene on the scale of rugs and carpets. In the end, what they got was sort of liquids, black liquids. That is graphene, as you well know, because I made that in my cellar a few years ago. It's still around. This one is a graphene powder made by Graphene CR. And we'll talk about that in a minute perhaps. But the point was that people saw these black liquids and powders and thought, oh, is that it? And the hype, the expectations went right up and then crashed back down. And in the early days, when people started to put graphene into things, they suddenly found that instead of making things better, it made it worse. And over the intervening years, what people have figured out is that you actually need to add less of these powders rather than more to get the effect. You remember back in when we were talking about the amount of graphene in concrete, it's 0.01%, tiny, tiny amounts. So that's counterintuitive. So the other type of graphene, this is made by Groltex, who you and I both know, Jeff, who runs the company there in California. And what you can see on here, on that surface there, that's a single atomic layer of graphene. So it's this stuff on the surface of copper foil. And his company, as you know, Liam, he's developed a process for getting graphene off, transferring off to be used in other sensors, other devices such as sensors and things. I think that's where I think Jeff's company is making some headway at the minute. So we've got graphene film and graphene powders. So that's the difference between the two. What are we seeing the most activity in? Well, do you remember at the beginning I said graphene composites? Yeah. So graphene composites are taking that powder and mixing it with plastics and then enhancing the properties. And particularly, it started off being added into things like polyethylene, but now we're starting to see it being added into recycled polymers as well. So we've got the problem is when you try and recycle plastics, the chain length gets shorter and shorter, so they get weaker and weaker the more times you recycle them. But if you add graphene in while you're recycling them, you can preserve the strength for longer, which means you can recycle the graphene, recycle the plastic many more times. So that's where we're seeing commercial activity, plastics, composites, that sort of stuff, and then also in roads and concrete we talked about.
Oh, thank you. Yeah, so still on the company side, and just got a couple more bases to cover now. Rather than the products themselves, if we take a look at the companies behind, either behind making the products or behind actually producing graphene, you keep a good track on share prices, companies, what's coming out, in out. Now, which companies should people, keep an eye on over the next few years? And with NGA looking at the US industry, is there any that are in the US that should be kept an eye on, as well as globally? Because obviously you have a good track on Europe as well, and that's where a lot of the hub is. But around the world, where should if people are looking at graphene companies to keep an eye on, who should we be looking at?
Well, this might sound like a little bit of a cop-out, but I want to give you a sustainable answer in both senses of the word. So rather than mention specific companies, if I did, the reason for seeming to be a little bit cagey about this is, if I tell you now, things are moving so fast, the information is going to be out of date by the time people watch this. And I suppose the best way of describing this is, look for graphene companies that are making graphene sustainably. I think they're the ones that are going to be the real ones to follow in the future. Graphene's already entering products such as the plastic composites used for Ford cars, as we said already.
Yeah.
And now pretty much every single Ford car made has got graphene in it. So watch what's going on in America over there. Also, the other thing is watch what is happening in Australia. That's coming up on our radar. There's a lot of activity commercializing composites that we're starting to see coming out from there, and particularly any firms that are supplying into that market, and particularly if they're supplying sustainable graphene. I think that is something else to watch. Europe, curiously, there's a lot of research activity, a lot of noise, but in terms of volume production examples coming through the market at the minute, I'm having a tough time sort of pinning anything down. I'm hearing lots of noise, not a lot of action.
That's interesting, because it's normally, you know, EU's the hub, which obviously there's a lot going on, but
yeah.
interesting.
The other thing as well is China. There's a lot of activity in China with graphene, as you well know, particularly in mobile phones.
Yeah, there's always been a lot of activity going on in China. We just don't hear about a lot of it.
Yeah. So it's a slightly cagey answer, but I tried to sort of answer that in a sustainable way as possible. So
and without name dropping, and
somebody will watch this a year, maybe 2 years from now, and hopefully that answer would still be helpful rather than
relevant, rather than
some firms, which may not be doing as well as some others. The pace of change in this whole market, we're watching this month by month, and it is really, really exciting and moving fast.
Yeah. Oh no, yeah, that's fair enough. I can understand the answer behind that. Which brings me on to my final question, and it's a question that I ask everyone, and it is: what impact do you see graphene having in society?
Ooh, big one. Well, graphene's already having an impact. It's making stronger materials in cars, particularly Ford. They're making lighter weight components, which means they can make more sustainably produced cars. It's beginning to start helping recycle materials such as plastic, so we'll get less going into our oceans and less going into landfill. One other thing, I suppose, which is worthwhile watching is what's happening in the biomedical field. At the moment, we're sort of in lockdown still, and the pandemic rages, so that's taking everybody's attention. There are other examples. There's a company which is making a graphene electrotherapy for treating brain cancers. So they're another spin out from Manchester University, and basically what they can do is they can make an electrically conductive graphene pouch that can go inside the brain when a brain cancer tumor has been removed, and then by feeding an electric current to it, it produces an electric field which inhibits the growth of the cancer cells once most of the brain tumor has been removed. And it's already shown to prolong the life of patients, probably double it. And we'll probably see things like that to sort of quietly come out behind the scenes. So I think graphene is probably going to penetrate most parts of our lives. We may not see it, you know, like computer chips now. They're embedded in everything. Graphene's probably going to be a bit like that. You'll see the benefits it creates with not necessarily realize that it's in there.
Yeah.
So I think it's going to have a massive impact. It's going to be part of the advanced materials revolution. And then once this stuff starts being made on a really large scale and you get graphene off, all bets are off. You've got a fifth industrial revolution happening then.
Yeah. Oh, very interesting. Good to know as well. But yeah, stealth mode graphene in everything is
Yeah, and there's a lot of stealth stuff going on, which we can't talk about. You know some of this as well as me.
Yeah, obviously we will start to see more of it emerging over the next few years.
Yeah,
definitely. All right. Well, thank you for joining me, Adrian. It's been really interesting to hear your insights, and I look forward to seeing what else is going to be coming out over the next few months and via the journal. And thank you for joining me on the video. And to everyone watching, thank you, and I will see you next time.